Hello, intermediate algebra students, and welcome to our first recorded notes of distance learning. This section of notes is on 8.3, graphing functions that are in the form ax squared plus bx plus c. These are full quadratic functions. This is also called standard form. So our learning target for today, I can graph quadratic functions in the form ax squared plus bx plus c. A, b, and c are all constants, or regular numbers. All right, so our vocab for today, we have minimum value, which is the y-coordinate of the vertex when the graph opens upward. So when you have a graph that's a parabola, it'll look like that. It opens upward. Let's see if I can zoom in on this. It opens upward. The vertex would be here. It's the y-coordinate of that vertex. That's called a minimum. And it's going to be a minimum when a is greater than 0, or when a is positive. That's that first number, that leading coefficient. All right, a maximum value is the y-coordinate of the vertex when the graph opens downward. So when a is negative, and the parabola looks like, and the parabola looks like that, then the vertex is at the top, so the y value is a maximum point. That's the highest that y will get. All right, feel free at any point in these notes to pause so that you can write down and record. I'm just recording the whole thing, so I'll just keep going. All right, our core concepts for today. When a is positive, so when a is greater than 0, the graph opens up. And when a is negative, or when a is less than 0, the graph opens down. So when that leading coefficient, a, is positive, y will continue to increase away from the vertex. And when a is negative, y will continue to decrease or get more negative away from the vertex. The y-intercept is c, that's that number at the end, which makes sense because when the y-intercept is what y is when x is 0, and when we plug in 0 for x, we're left with y equals c. All right, and then the main point of today's notes, the x-coordinate of the vertex can be found by using negative b over 2a. So the x-coordinate of the vertex is also the axis of symmetry. So that can also be found by using x equals negative b over 2a. We're going to get lots of practice using that today. Okay, and then here's a picture that just kind of illustrates all of that for us. We have our vertex at the bottom. The y-coordinate is the minimum or maximum. In this case, it's a minimum. The axis of symmetry, the x-point of that vertex, is x equals negative b over 2a. And in this case, a would be greater than 0, a would be positive, because the parabola points up, it opens upward. The next page. Okay, example 1. We're going to find the axis of symmetry and the vertex for each graph. All right, so in our notes, we said the axis of symmetry can be found by using x equals negative b over 2a. Now we're just plugging in the numbers b and a and solving for x. So b is 8. I'm going to plug in 8 for b, and a is 2. I'm going to plug in 2 for a. So then my equation is going to be x equals negative 8 over 2 times 2. 2 times 2 is 4, so I have negative 8 over 4. Negative 8 divided by 4 is negative 2. Our axis of symmetry is x equals negative 2. All right, so next we have to find the vertex. How we're going to find the vertex is we're going to plug in that x value for y so that I can find the y-coordinate of the vertex. So now I have y equals 2 times negative 2 squared plus 8 times negative 2 minus 1. Now, some of you might be wondering where that came from. Remember, f of x is just like saying y. So I took that equation that we started with, and I just plugged in negative 2 for y. So here's all my, wrong one. Alright, so I got negative 2 for x. I plugged in negative 2 where we have an x in the equation. Alright, and from here you can type that into a calculator. Otherwise you get y equals 2 times 4 minus 16 minus 1, which is going to end up being 8 minus 17, which is negative 9. So our vertex is at negative 2, negative 9. Alright, if you want to pause for a second and copy that down or make sure you understand where all those numbers came from, go ahead and do that. Alright, I will move on to example B. So we're finding the axis of symmetry using the equation x equals negative b over 2a, and then we'll plug that in to find y. So in this case, b is already negative. So when I plug in negative 2 for b, I have a negative negative, and a negative times a negative is positive. So when I plug in negative 2, it's just going to be positive 2 over 2 times 3, which if I simplify, it's going to be 1/3. And this is also our axis of symmetry. X equals 1/3. Alright, so now I'm going to plug in 1/3 for x. I'm going to solve for y. So I have 3 times 1/3 squared minus 2 times 1/3. Alright, 1/3 squared ends up being 1/3 times 1/3. When we multiply fractions, we multiply straight across. So that's going to be 1 over 9, 1/9. Minus 2 times 1/3 is 2/3. So then I have 3/9, which is 1/3, minus 2/3, which equals negative 1/3. So my vertex is 1/3, comma, negative 1/3. Alright, example 2. We are going to graph this quadratic function by using the vertex. So to use the vertex, first we need to find the vertex. We're going to find the x-coordinate by using our equation negative b over 2a. B is already negative, so when I plug in negative 6, it's going to end up being positive 6 over 2 times 3, which is 1. X equals 1. That also means our axis of symmetry is at x equals 1. Alright, I'm going to plug in 1 for x to find the y value of the vertex. Y equals 3 times 1 squared minus 6 times 1 plus 5, which ends up being 3 minus 6 plus 5, which is positive 2, which means our vertex is at 1, 2. Alright, so I'm going to graph that point at 1, 2. There's my vertex. Now, just by looking at the equation, I can also find another point on the parabola. If you look back at the notes, at the vocabulary at the beginning, remember it said the y-intercept is C. So this positive 5, that's our y-intercept. So I can also plot a point at 0, 5. That's our y-intercept. So I know part of my parabola is going to look like that. Now remember I said that x equals 1 is also the axis of symmetry. That means there's going to be an imaginary line at x equals 1 where the graph is symmetrical. If that parabola is symmetrical, that means that I can reflect that left half over that axis of symmetry, and there's going to be another point right there. So now I can picture where both sides of my parabola are, because I can graph the point 1, 2, where the vertex is. I can graph the point 0, 5, where the y-intercept is. And after reflecting it over the axis of symmetry, I can also plot the point 2, 5 by reflecting that y-intercept. So now I have a parabola. I graphed the function f of x equals 3x squared minus 6x plus 5. Now the second part of example 2 is to describe the domain and range. Remember, domain for quadratic functions is almost always all real numbers, which is not any different in this case. So domain is all real numbers. There are two arrows pointing in both ways, both directions for the x values, so x can be any real number. The range, or y values, has to be greater than 2. So if you notice, 2 is the point where it turns around. The parabola turns around, so y can't be any less than 2. Y has to be greater than or equal to positive 2. All right, example 3. Determine if each function has a minimum or maximum value, then find the value. So again, we're going to find the vertex, but first I want to figure out if it's a minimum or a maximum. If you look back at the vocab, a minimum was defined as the lowest point on a parabola, the y value of the lowest point when the graph opens upward. That's our minimum. And then the maximum was the highest y value when the graph opens downward. That's our max. Now in example A, our A value is negative. That negative means that the graph is going to open down. So this vertex will be a maximum. This is a max value. All right, then it says find the vertex. So first we need to find x. X equals negative b over 2a, which is 24 over 2 times negative 4. That 24 is positive because both b and 24 were negative, so the negatives canceled out. So now I have 24 divided by negative 8, which is negative 3. X equals negative 3. All right, then we're going to plug that value in to find y. So I have y equals negative 4, 3 squared, minus 24. There's a negative 3 squared. Minus 24 times negative 3, and then minus 19. All right, so you could plug this into your calculator. I'll go ahead and show you how it's worked out. So we have negative 4 times positive 9, and this is plus 72 minus 19. Which ends up being positive 17. So our vertex is at negative 3, 17. Our maximum is y equals 17. Our vertex is negative 3, 17. All right, part B has a positive a value. 8 is positive. Because it has a positive a value, our graph will open upwards, making our vertex, the y value of our vertex, a minimum. All right, then we need to find that vertex. So first we need to find x. We have x equals negative b over 2a, which is going to be positive 8 over 2 times 8. If you simplify that, it is 1/2. X equals 1/2. Then we're going to plug that 1/2 in to find our y value. So I have y equals 8 times 1/2 squared minus 8 times 1/2 plus 6. Now 1/2 squared is like 1/2 times 1/2, which is 1/4. So I have 8 times 1/4. Half of 8 is 4 plus 6. 1/4 of 8 is 2. So that's all equal to 2 minus 4 plus 6. And 2 minus 4 plus 6 is 4. So our vertex is at 1/2, 4. Our minimum value is y equals 4. Our vertex is at 1/2, 4. All right, now this next example was used to explain Graph and Calc. So if you do not have the app Graph and Calc on your iPad yet, there is a link in the 8.3 assignment, because you'll need it for the assignment today, with the Graph and Calc directions. So make sure you go ahead and check that out and download Graph and Calc. All right, example 4. The height in feet of a golf ball that is hit from the ground can be modeled by the function f of x equals negative 16x squared plus 96x, where x is the time in seconds after the ball is hit. Sketch the graph after graphing it on Graph and Calc. All right, so I'm assuming at this point you have Graph and Calc, you've graphed it on Graph and Calc, and you know that the graph looks something like this. Assuming that this point is 344, and then this is 6, 0. This point is 0, 0, the origin. All right, so the graph should look like that. All right, so to determine the ball's maximum height, that would be the y value of our max. So the maximum height is 144 feet. And then it says, find out how long the ball is in the air. This is really asking for x-intercept again, and the function reaches the x-axis at 6, 0, which means the ball was in the air for 6 seconds. Again, the point of this example was so that you could use Graph and Calc to see it, so I hope you have Graph and Calc and you've tested this out, typed it into that calculator, and your parabola matches up. All right, students, thanks for tuning into the notes for today. Just some summary questions. When you are given the function ax squared plus bx plus c, you can determine the axis of symmetry by using the formula x equals negative b over 2a. That was a huge part of the notes for today. And then to find the y coordinate of the vertex, you plug in x to find y. How do you determine if it's a maximum or minimum value? You can determine that by looking at a, this a. If a is positive, then the graph opens up, which means it's a minimum value. So if a is positive, it opens up, which means it's a minimum. If a is negative, the parabola opens down, which means the vertex, the y value of the vertex is a maximum. If you need to graph using a pencil and piece of graph paper, some steps for graphing it could be to find the vertex and then use the y-intercept, and know that that y-intercept is then reflected using the axis of symmetry. You could also graph it on Graph and Calc, and that can help us to solve some real-world situations. All right, now that you've completed the notes, there is an assignment linked in the 8.3 Day 2 for April 6th. You can also check out the Khan Academy video for some extra support. Have a great rest of your day.